We are a four-man team consisting of Qiao Liu, Wen Yilu, Li Miao, and Ci Zhang. Our project is called Zai Zai Search, which is a Chrome extension to the current UIUC course catalog search engine. Firstly, we will take a simple overview of the current existing course search utility available on the course catalog website. We will further discuss the crucial limitation of the current system, and by doing so, we will establish a basis for our solution and why it is a necessary improvement. A detailed walkthrough of the implementation procedure is also provided with a few demonstrations of our Chrome extension at work. Lastly, we will be providing a quantitative analysis of our method and give further insight into the possible future improvements. So, for those of you that aren't familiar with UIUC's Search Course Explorer page, here is how it looks like. It is a separate website from the more renowned enterprise system. The picture is a bit difficult to see, but here at this page there exist certain filters, for example, year, term, college, and so on. The system does perform searches for you. However, for those of you that have ever really interacted with this particular search function, you've probably find it to be unreliable. Firstly, the biggest issue with this particular system is that it can't handle vague or general query searches. For example, it works fine when one searches the term parallel computing. The course CS591 is returned, and in this case, this is the accurate result it should generate. However, when a more general topic such as programming is inputted, the system returns the full list of all courses offered at the university in alphabetical order. Furthermore, the system also lacks overall accuracy when dealing with specific query terms. For example, when input is web design, the system returns GOUR 199 and LIS 590, two completely unrelated courses. Additionally, as you may have noticed earlier, the current search system also lacks more useful filters, such as day of the week, desired time, availability, and so on. So, due to all the lackluster features of the current implementation, our goal is to provide a more robust search process for UIUC's Course Explorer. Specifically, we aim to improve upon the current deficiencies, and maybe even introduce additional features. The primary goal, of course, is to increase the accuracy of the search results. By accuracy, we mean both the precision of results and also allowing the system to be able to process general query terms like programming as well. We will also provide two additional filters, course availability and time of the class. One established feature we will also provide is the cart. This is where students can essentially shop for classes they are interested in, and by going to the cart, they can directly compare these classes. There is also room for even more additional features such as a recommendation system. These potential features will be discussed at the end of this presentation. One small improvement we also try to establish is the aesthetics of the web page as well. This is a screenshot of our project. As mentioned previously, we have two additional filters, availability and time, where time is in the form of the course conflicting with the user's current schedule or not. As demonstrated, under the CS department, when the user searches system, the search engine returns the top 3 most relevant courses. In comparison to the current web page, Course Explorer will simply tell you the term system is too common to be searched, even when the topic area, computer science, is also selected as the subject. Now we will go into the actual theory and implementation of our solution. The general process is already highlighted here in this slide. A few things to point out is that the crawler obviously stores and crawls data locally. and all further processing is done with the locally stored data. One might question the real-time validity of our system then, but we've noticed that the Course Explorer system itself only updates every 20 minutes. Therefore, all we need to do is to ensure our locally stored data is updated at the same time frequency. We will now go into more specific of each step of the implementations. So for the data crawling part, to parse the HTML style text, we use the Python Beautiful Soup library. Simply put, given a root page, course listing for a given department, we can traverse the course web page hierarchy to build a list of courses and their associated metadata such as location, instructor, time, and current status. The current status is like whether it's closed or open or restricted. So for the front end, we used Bootstrap component to construct basic interface. Then we used jQuery to interact with users' actions. After that, we parsed keywords entered by the users. Lastly, we produced a URL and used the get method to fetch data from the backend asynchronously. Now, for the backend, we have every course's information, such as description, course name, etc., contained in a separate document. And then we do the inverted indexing to sort documents. All the documents will be combined to be a corpus. Lastly, we built a VSM, which is the vector space model, to measure the similarity between query and the documents. So the output is that we will return rank top 3 related courses. Since our project is a Chrome extension, you need to open Chrome first and click on our extension, and there will be a pop-up. So after input system, and you will see like all the related courses, and you can use our filter to filter out the closed courses. Then you can add the course you want, in this case system programming, into the cart for further comparison. In this slide, we basically show how to add more than one courses into our cart. First, we type in system, and we can see all the courses related to system. In this case, we add like CS424 real-time systems into the cart, and then we search for paralleling programming, and we hit search, and we will see there are so many courses, and we add the advanced operational systems into our cart. Did the evaluation manually. For the first example, we used system as the query, and we got 3 results. After evaluating them manually, we found that all 3 results are actually indeed related to a system. So that's a 3 out of 3, that's 100 precision. Also, after going through all the courses in CS department, we found that there's in total 3 courses related to system, which makes it a 100% recall as well. However, for the second query, which is paralleling programming, there are in total 4 related courses. However, our system only returned 3 because the default for our system returning is 3. So that's unfortunately a 75% recall. Also, all the returned courses are descendingly ranked by the importance score to the query. There are many ways to further improve our current project. The first one is that we can experiment with different text retrieval functions and to see which one is the optimal. Now, currently we are using a vector space model. Second, we can implement a machine learning process to further increase recall and precision. And also, the machine learning process can provide the possibility of establishing a recommendation system. Third, we can obtain further information regarding courses, like information from the course syllabus or like the flow chart. So that requires additional information provided by the college and or the professors. But it will significantly improve performance with more data. And that's all. Thank you for listening.